So, problem 5. At a super slippery, icy intersection, a Beetle driving west collides with a beer truck traveling north at roughly the same speed. The two vehicles stick together and slide. Compare the forces of the Beetle to the force of the truck. So, for this, I already wrote these out. The force of the beer truck exerts on the Beetle is the same as the Beetle exerts on the truck due to Newton's third law. Part B. Compare the change in momentum of the Beetle to the change in momentum of the beer truck. Momentum is conserved in the collision. The change in momentum is equal to the change in momentum of the Beetle. They are the same. So C. Compare the velocity of the center mass of the beer truck and the Beetle before the collision to the velocity of the center mass immediately after the collision. So VCM, I did the velocity, so the mass of the Beetle velocity times velocity plus the mass of the beer truck velocity over the mass of them both combined, which equals the mass of the beer truck plus the mass of the Beetle times the initial velocity over the mass of the boat plus the mass of the beer truck. Those cancel out, so it's just VI. Velocity center mass final equals the mass of the beer truck plus the mass of the boat times the velocity over the mass of the boat plus the mass of the beer truck, and that cancels out, which gives you VF. So then you can set them equal. The initial equals the final, and you get out VI equals VF. And then the velocity of the center mass remains constant immediately after the collision. So, part D. Compare the magnitude of the Beetle's momentum before the collision to the magnitude of the Beetle's truck momentum before the collision. So, this is which part? Compare the magnitudes. So, for the beer truck's momentum has a larger magnitude than the Beetle's momentum before the collision. Part E. Compare the total momentum just before the collision to the total momentum just after the collision. So for this, the total momentum just before and just after the collision is the same. This is due because momentum is conserved in this collision. Part F. Compare the total kinetic energies just before the collision and the total momentum just after the collision. And this was kinetic energy lost because it's inelastic. And the final part, what non-conservative forces, if any, do work in this collision? So the non-conservative forces do work by determining the two objects that collide, which is the truck and the Beetle.